Welcome everybody to the Homeschool Plus conference, and I'm happy to introduce you to Aravinda Pillalamarri, who was born in India, and as historians say, 0 first appeared as a number in its own right there in India. Aravinda aspires to slow learning, slow food and slow money. She walks most places and is planning to get a bicycle. An unschooling mother, she delights in every discovery her daughter makes. Married to a physicist, she drinks in details of symmetry, spin and dark matter. She works for the Association for India's Development on Women's Empowerment in Health, Birth and Livelihood, and writes about peace, justice and sustainability on the home front in her blog Ask Amma, askamma.wordpress.com. I'd like to thank our sponsors and supporters, Homeschool Life, G3, Home Education Magazine, and of course, Blackboard Collaborate. And if everybody would like to tell us where you're from, on the left of the whiteboard, there are tools. The second tool is a star or a sun. If you'd like to tell us where you're from, and also write in the chat box where you're from, what you do if you want, what the time it is where you are, and what the weather's like. Okay, so if everybody like to let us know where they're from, yeah, that's me putting the smiley on. I've got it quite right, never mind.
Hi, Maisie. So nice to have you here.
Oh, I see my thing is gone. I shall put it down again.
I didn't know you were logging in from Israel.
Yes. Do you want to put yourself down as well?
Oh, where? Where do I? Oh, just here in the chat section?
No, not on the chat. If you look at on the left of the whiteboard, there's like a there's a smiley now. If you go to there,
Smiley.
And if everybody else can, let us know. And there we have Serbia, Dijan from Serbia.
So you click on the smiley face?
Yeah, and then put it where you are in India, and let us know also in the chat box. It's nice.
I see. Is there supposed to be a map? Are we supposed to?
Can you see the map?
I don't see the map.
Okay, well,
I see that we have Dejan from Serbia. That's nice.
If people are having problems putting their symbols on the map, then write in the chat box. Okay, so everybody's done that. And where are you from in India, Aravinda?
I am from Andhra Pradesh. It's in the south.
Oh, nice.
Have you been there?
To India, no. My some of my children have, yeah. Actually, I think only one of my kids. There, it's gone again. Okay, so thank you everybody for letting us know where you're from. I'll hand it over to you now, Aravinda.
All right. Thank you, Maisie. So really happy to have the chance to share some of my observations. As Maisie said in her kind introduction, I do delight in every little discovery that my daughter makes, and that's really what inspires my article. So I really have to thank all of you for indulging me in sharing some of these observations here at the homeschool conference. But I do think there's something there that I feel would be useful. So let's see how it goes. Let's see, can I get to the slide? Yes, I can. Oh, the fonts didn't come through. Well, it would have been a little more beautiful if my fonts came through, but so such as it is. I almost didn't have a presentation, so let us begin. I'm just curious if Bill is online. What does MHLA stand for? Is it some kind of a mathematicians association or something? Bill is typing. I'll just wait in here. Home learning. Okay, it's like Mathematicians Higher Learning Association or something. So anyway, let us begin. So can you imagine a time before the discovery of zero? So this is something that my husband and I got a glimpse of through our daughter when she was just 2 years old and discovered zero. So this was not the discovery of zero in the history of the world, but in her life, she discovered zero, and it was not a happy discovery. She learned to count without much ado, but when the numbers became numerals and the number 10 appeared on the page, not with its own symbol, like 1, 2, 3, 4, 5, 6, 7, 8, 9 heads, but with a 1 and a 0, then suddenly everything had changed. Until that moment, in her world, you had a numeral for every number, and this reminded me of a character I read in a Borges story. The story was called Funes the Memorious, and the character is Ireneo Funes, and he doesn't use a base 10 or any particular base numbering system. He just has every number has its unique name. He has an infinite vocabulary for the natural series of numbers. Every number has its name, and it just goes on forever without a pattern or repetition, no use for the concept of place value, which is what I had to suddenly explain when we got this number 0 coming unceremoniously in the number 10. So when our daughter saw that the numeral 10 comprised a 1 and a 0, she flung herself upon a chair and cried. So we were not at all prepared for her to be so upset by this, otherwise simple fact. So we were unprepared for the blow this dealt to her understanding of number and how she would struggle to make sense of it. And what I realized in retrospect about this struggle is that this was a struggle of an artist. Because the world had changed in a fundamental way. Something was lost that would never return. Why would there be a 0 in the number 10? Till now, the numerical representations were incidental to the concept of number. How we write 8 had nothing to do with the meaning of 8, the value of 8. But in the number 10, that's what I mean by there was a fundamental change. Suddenly, the way we write it has something to do with what it means, what number it is. So this concept of number, this quantity, this thing that could go on forever had now abruptly, jarringly come back to 0. And this is what she had to figure out. And being somebody who just took all of this for granted, I didn't know. I didn't want to diminish the scale of her problem, and yet I didn't have any suggestions as to how to approach it. But hold on, let's just wait and see what can, as an unschooling parent, what do you do? But wait and see how the child leads her way out of this quandary. Sometime later, she confronted a blankness of another kind. It's still around the age of 2, 3 max. In tears, she ran towards me holding a white crayon. Let me see, do I want to go to the next? So I'm pressing the arrows. I'm trying to go to the next slide, but it's not coming. Yeah, it's okay.
Do you see where it says follow? Follow me?
I see follow. I see the two arrows.
An arrow. Sorry, a V, a tick on it.
It's checked, yes.
Okay, so I've just done it for you.
Okay, can you go to the next one? So, does it say?
You are what you believe.
Oh, okay.
All
right. Well, okay, that's okay. I wanted the one before that, but we can stay there. That's okay.
So I'll go there. White crayon.
White crayon. That's all. Okay. So just like zero, we had a moment of fundamental frustration regarding the white crayon. Okay. Sometime later, she confronted a blankness of another kind. In tears, she ran toward me, holding a white crayon. It didn't show up on paper. She cried. Therefore, I am throwing away the white crayon, she declared painfully. Her eyes brimming over pleaded for a way out of this harsh sentence. Now we can have the next slide. This is not my drawing, by the way. I just found it as an example. I drew something with the white crayon and painted with watercolor on top of it. The watercolor surrounded the crayon image to reveal it. Saved. In its own way, the white crayon was a placeholder. So are we looking at that drawing? Oh, we can go to the next slide, the white crayon, slide 3. Yes. So that's just to give an example of the white crayon used as a placeholder, even though it doesn't show up on the paper by itself. After the watercolor goes over it, then the white crayon is actually part of the art after all. And this is how I saved the situation that time with my daughter when she was around 2 or 3 years old. So I just start with these two examples, and now I will relate them to some of the discussions on the teachings of on how we teach mathematics, in large part inspired by Paul Lockhart's work, A Mathematician's Lament, which many of you may be familiar with. So thinking back to these two moments where my daughter was literally in tears over understanding what I recognize in both cases to be a mathematical concept, whether it's zero or the white crayon. We often hear people describe the joy and exultation of mathematics, but rarely the pain and suffering, arising not from inability, but rather from the wholehearted engagement with the ideas in all their beauty and tragedy. Immense was my gratitude when I came across a mathematician who wrote, and I think it's in the next slide. I've placed it in the net, yeah. Mathematics is the music of reason. To do mathematics is to engage in an act of discovery and conjecture, intuition and inspiration, to be in a state of confusion, not because it makes no sense to you, but because you gave it sense and you still don't understand what your creation is up to have a breakthrough idea, to be frustrated as an artist, to be awed and overwhelmed by an almost painful beauty, to be alive, damn it. Paul Lockhart, A Mathematician's Lament. And coming back to the example of zero, which so puzzled and frustrated our 2-year-old daughter. A few days later, our daughter explained to us that in the number 10, the 0 stands for 9 numbers. In the number 100, the 2 zeros stand for 99 numbers. So that's what she said, and now I'm going to interpret what that means. So if you had to subtract, say, 6 from 10, you could subtract it from 9 instead of from 0, and then add the 1 to get the correct answer. Of course, no one would ever do this because when you start doing single-digit subtraction, you have your 10 fingers and no zeros are involved. But try it in 2 digits. If you have to subtract 42 from 100, you could just subtract it from 99 instead of from 00, and then add the 1. We didn't do that either because by the time she started doing subtraction on paper, her resistance to 0 was long forgotten, and she learned to borrow funny word, but numbers can be funny that way. More importantly, it doesn't matter that we didn't use her method to subtract. What matters is that she thought about it and explained the solution to her problem. How often do we get a chance to appreciate the creative and expressive side of mathematics? Too often people see it as a mechanical process, and if at all they believe in the beauty and thrill of mathematics, they perhaps feel it comes only to those who master its mechanics to a highly advanced level. Passionately opposing this approach to teaching mathematics, Paul Lockhart, who teaches in St. Anne's School in New York, wrote an essay called A Mathematician's Lament. First circulated privately, it was eventually published by the Mathematical Association of America, followed by a sequel, and expanded into a small book. May I have the next slide, please? Lockhart says, I want students to understand that there is a playground in their minds and that that is where mathematics happens. He insists that mathematics is an art. If the world had to be divided into the poetic dreamers and the rational thinkers, most people would place mathematicians in the latter category. Nevertheless, let's see if I can. Next slide, please. Nevertheless, the fact that there is nothing as dreamy and poetic, nothing as radical, subversive, and psychedelic as mathematics. The fact is, it is every bit as mind-blowing as cosmology or physics. Mathematicians conceived of black holes long before astronomers actually found any, and allows more freedom of expression than poetry, art, or music, which depend heavily on properties of the physical universe, like our white crayon. Mathematics is the purest of the arts as well as the most misunderstood. Well, I'm sure every artist would be able to defend their art out there, but it's interesting that as a mathematician he also enters the fray. Lockhart wants children to have the opportunity to observe mathematicians at work practicing mathematics the way they see musicians sing or artists paint. He also wishes that it would be taught along with its social and historical context so that we could explore such questions as why did these mathematicians discover these things at these times in these places? Because the people, not only their formula, matter. In spite of mounting pressures to the contrary, teachers like Lockhart are doing what they can to bring humanity and adventure into the classroom. Lockhart urges teachers to play games such as chess, Go, hex, to do puzzles, and be willing to get their hands messy and express their ideas through math. Mathematics is an art, he says, and art should be taught by working artists, or if not, at least by people who appreciate the art form and can recognize it when they see it. And I'll just, as an aside, I've shown this article to some people, some mathematicians as well in the university, and one of them, I mean, this was the sentence that really got him because he was wondering, how you can really do this. And certainly you can't, it may happen sometimes, but how can you do this as a program? So I don't know how you would do this as a program. I am just capturing the moments where it happens in our life. But if you wanted to make a system of teaching mathematics this way and teach it, do mathematics in front of your students as an artist does art, I don't know practically step by step how that would work. So that's really very much an open question. Continue. Observing children learn gives us a second chance to appreciate mathematics as an art form. So again, like I said, this whole thing is based upon my experience as a parent, not as a teacher on a daily basis. But this is something that really has hit home for me, that since my daughter hasn't learned in a classroom but has explored mathematics through her environment and doesn't, it doesn't have to be told that it's an art form, but it, inherently sees it in separate, not separate from art and any other thing. It has opened my eyes to seeing mathematics as an art form. Even one such moment of struggle with the meaning of zero can inspire confidence in our capacity to probe the depths of ideas, if we are allowed that moment. As artists have urged us to stop telling children what color to use or where to draw, we must also allow for creative expression in the discovery of numbers. We ought to refrain from intruding into the pre-numerate state with our preconceived notions. We should allow every child to investigate from scratch as if the world had not yet settled on a numbering system, adding system, dimensional system, and so on. Would we want to skip the stage when little ones make up their own words and move expeditiously to standardized language? If we delight in the words and usages invented by our little ones, it is because we are so confident in our own language that we are free to tinker with it, to produce as well as consume. So if I had one plea to people who are, want to know what to take away from my ideas on the beauty of mathematics, is do not teach numbers to young children. Please leave the field open for children to discover numbers. Just as they make up words, let them make up numbers. Let them make up numbering systems. And I really think that if we as adults and as a society, as a community, felt more confident, less afraid of mathematics, and did not see mathematics as a threat to be cautiously, to arm ourselves against, but rather as an art to embrace, we would allow children the freedom to play around, to invent, to imagine, and not consider it wrong. Just like we don't consider the words that children invent as part of baby talk, we don't consider them wrong, generally. There may be people who discourage that, and I would say that those are people who are maybe learning English as a second language, or are from backgrounds where they aren't necessarily confident that their grammar and vocabulary are up to standard, and therefore they're more concerned that the next generation should not repeat their mistakes. But then the pendulum shouldn't swing so far that their scope for creativity and imagination and inventiveness is so far constricted, which I believe is the case that we face today with mathematics as a society, as a whole. And if I'm arguing for anything, I'm arguing that we let go of that and let children invent things. So I observed this with one of my friend's children. She was not even 2, and she started counting. And she was maybe almost 2 years old. Anyway, she started counting things, 2, 2, 2, 2, 2. At least it sounded like counting. I mean, I don't know if it was counting, but we don't always get it. We are eager to translate it into what we understand. But anyway, this is what she was doing. If we believe there is something there to get, then we won't rush to correct it. We won't rush to tell her, no, that's not how you count. You have to count 1, 2, 3, 4. Just like we, take some delight in baby talk. Her parents and other observers thought it was kind of cute that she was saying 2, 2, 2, 2, 2. So, so that's, I encourage that we believe in our children's capacity to puzzle things out, and therefore we're not tempted to give away the ending or what we think is the end of such an enterprise. Eventually, she did start saying, now she's 4 or 5 years old, I'm sure she's forgotten all that, but just the chance to tinker around with the concept of 2 being, not 1, being another. If you translated that 2, 2, 2, 2, 2 into something we understood, instead of trying to correct it and make it 1, 2, 3, 5, you could translate it as another, 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 and then you would understand more of where she was coming from, and see that she wasn't so much counting, but seeing the difference between 1 and not 1, 2. And not just at such an elementary level of discovering numbers, but even now, even at what we might consider more advanced levels of mathematics. For example, recently, our daughter struggled with the concept of negative exponents. A few days later, she extended the Cookie Monster song from Sesame Street. Okay, the song goes like this: 1 cookie and 1 cookie makes 2 cookies. So she just kept going with it. 2 cookies and 2 cookies makes 4 cookies. She just took it all the way up to 256 and used it to explain the powers of 2. And it works for negative exponents as well. 1 cookie and 2 people makes half a cookie per person is understood. So what I find is when we share stories like this, every parent has one or many such stories. This kind of thing becomes commonplace when you recognize that math is everywhere and just allow its time and space to come before you. Shapes and patterns in nature, ideas in our mind, games we play, the doodling we do, the rhythms we tap, all lead to mathematical discovery. As coming back to quote Lockhart's essay, Mathematician's Lament, as Lockhart says, if everyone were exposed to mathematics in its natural state, with all the challenging fun and surprises that entails, I think we would see a dramatic change both in the attitude of students toward mathematics and in our conception of what it means to be good at math. Practicing mathematics as an art form is nice work if you can get it. Vi Hart, who calls herself a mathemusician, shares her artwork through Khan Academy and her YouTube channel. Sharton Poskett's series, Murderous Maths, contains stories full of historical and imaginary characters involved in various mishaps and misadventures using plenty of math, which the author explains along the way. Popular internet sites like Numberphile air fascinating math puzzles and problems with guest mathematicians from universities and research institutes around the world. What these artists have in common is that it is hard to watch or read their work without wanting to try it out yourself. What if you never meet such artists and mathematicians? If I were to paraphrase Picasso, I might say that every child is an artist and mathematician. The problem is how to remain an artist mathematician once we grow up. So now I'm going to try to go back and address the what I call the open question, which one of my friends who's a math professor asked me, how do you actually do this? So again, I've not taught, at least not for many, many years, but certainly not, none of this comes from teaching experience. It's just life with my daughter. So speaking to probably more unschooling parents, as the focus audience, if we were to ask how to, I mean, suppose you ask someone who takes for granted that we learn without schooling, how do you learn? They might reply with, but how do we not learn? We're always learning. Don't look for a book or a class that tells you how to learn from life. You're already learning. So you hear that answer and you might suspect that even if they didn't know of a book that explained unschooling, they would rather you learned about it from life than from any instructions. However, even among unschoolers, mathematics often gives rise to uncertainty and hesitation. Thanks in part to classroom experiences that resemble not so much a playground as a factory, many grow to dislike or even fear mathematics. As adults, they are out of practice in delighting in the mathematical puzzles and riddles that present themselves to the hungry mind. In an effort to set their children free from their own limitations in math, they may follow a textbook curriculum for math, or they may decide that if learning math from life takes you no further than making change at the store, doubling recipes, or filing taxes, so be it. If it didn't come up in life, the argument goes, what do we lose by skipping algebra? Either way, you can keep your mind open to the wonders of mathematics. So here are some steps. Unlock the playground. If you weren't allowed to explore the mathematical playground of your own mind, empower yourself to open the gates now. Don't deprive your children of the thrilling rides inside. Check yourself when you groan, cringe, or roll your eyes, or otherwise express impatience or underconfidence about math. 2. Trust your imagination. Don't worry too much about the order in which we learn math. Get a math book that doesn't go in order, such as Murderous Maths or Mobius Noodles. I should point out these aren't math books that teach you how to do math. These are math books that help you unlock the playground. You will, if you want to learn how to do things, you probably will still have to go to other resources. But these are the books that will help you unlock the playground. Young children already have the imagination that invents and grapples with the puzzles of algebra, geometry, calculus, and all the rest. Speed and accuracy is good, but it is not urgent. From my own experience, even though I have observed all of these things and delighted in them and found it all wonderful, I did also sometimes worry that my daughter wouldn't be able to enjoy learning abstract concepts in algebra and geometry without first memorizing her arithmetic facts. Just knowing them by recall, all the kind of basic addition, subtraction, multiplication, I felt that they should be done and then we could move on. But as it turned out, it was not a problem. All could go on in parallel. Arithmetic is patient. Arithmetic is kind. It is not proud. Next, build your confidence. Confidence in your own learning is a powerful antidote to worry over your children's learning. I guess we should go to the next slide. Maybe I can have the next slide, please. Yeah. Oh, okay. These are just part of the playground. Okay, I'll just finish quickly. Confidence in your own learning is a powerful antidote to worrying over your children's learning. This applies to math as much as anything else. Your kids can learn math even if you don't, but if you seem afraid to do it, what they may learn is fear of math. Fear not. To quote Mobius Noodles, one of the books I mentioned, what should I do when my child makes a mistake? Take the answer and love it, and find a problem that would fit. Talk back. Just because you use a math book, you don't have to be a passive consumer. My daughter says you can also correct your textbooks, even if it is only grammar. Sometimes she critiques a story problem for its viewpoint or its failure to state assumptions. Don't be afraid to play with numbers, shapes, symbols, and stories. Just a few more tips. Learn together. On Khan Academy, my daughter and I use a feature that allows me to be her coach and her to be mine, so we can track our progress, recommend topics to each other, look at each other's graphs, badges, energy points. Love your mind. For life learners, this should come naturally. This is what frees us to follow our digressions, tangents, even our errors, fearlessly and cheerfully, with faith that our mind will not stop until the circle is drawn, no matter how large the arc grows along the way. Let it grow for math as well. Imagine, what if a generation of people were trained to bake a variety of dishes and eat them so often that they dreaded the sight of them? Their children do the same. No one likes any pastries, roasts, or casseroles, but they are required to eat them. Eventually, somebody decides to break free, refuses to learn advanced cooking, and bakes only flat bread. No more pizza, muffins, no more croissants, casseroles, or pie. To someone who loves math, that's how it feels when someone says, we don't need algebra, geometry, trigonometry, and calculus. When did I ever need to know the Pythagorean theorem? Why do I need to find the slope? In the public dialogue on education, we are hearing retorts like this more often. While schoolgoers can blame the methods used in textbooks and standardized classrooms, homeschoolers and life learners must take responsibility for their own learning. This slide just shows a couple of examples of our mathematical playground. The first slide is just our homeschool group, which made a geodesic dome, and the other slide is actually Shartan Paskett, the author of the Murderous Math series, and we had the chance to meet at one of his public lectures. And next slide, please. I have the list of references. So these are some of the things I referred to in my talk, and so I guess, let's see, I'll read down the, I should have recognized your name! Maria, oh God. I read the book, but I didn't realize that you were a co-author. Oh, okay, that's wonderful. So now I feel very happy that you were here. And so we have about, I think, 15 minutes left if anyone wants to ask any questions, share any comments. I hope everybody's able to talk. Maybe you can make sure people's talking permission is on.
Yeah, if someone wants to ask a question, just directly under your name, is a hand. If you could press that, then I can give individuals. Okay, Maria, I'm going to give you. Oops, sorry. Maria, you can go ahead and speak.
Hi.
Hello, Maria.
Thank you for the presentation, for your stories. It's nice to talk with you in person. I remember seeing you around the internet, and I'm glad you found the book useful. I want to ask you about the kids and something you mentioned about. Well, one of the worries I think of parents is this relationship, the worry that arithmetic will not happen. So you see it happening in your case, but you yourself love mathematics. You recognize what your 2-year-old does as mathematical. You see mathematics everywhere. So what parents tell me sometimes is, well, but if I don't do worksheets, I can't just find arithmetic or mathematics everywhere, so I can't unschool it. How would you address this? Does my question make sense?
I didn't hear the last part. If the parents say, if I don't do worksheets, then
the parents say that only people who are mathematicians can unschool mathematics or play with mathematics. And they say, well, I don't have the knowledge to do that. And as much as I try to convince parents themselves to play, it's hard going. So do you have any advice on that from your group?
I see what you're saying, and I think I have also seen a lot of parents also kind of say, oh, okay, well, you like math, so it's easier for you. But I mean, just ask yourself, would anybody say that I hate music, or I hate art, or I hate, flower gardens? And they may not know how to raise that garden themselves, but they would, not hesitate to take their child to the garden or to the musical performance. I think many of us have probably repeated this quite often. I feel like Paul Lockhart has done a great job at least addressing the theory, and I feel like your book, should be a tool in the hands of even the most timid parent to recognize and appreciate the mathematics that the children are already doing, and not stand in the way. That is I think that's something that comes naturally to unschoolers, but then they hesitate to apply it in math. That I don't know if I don't know what else. I see if somebody came to me with this, what I would do is give them your book. So I don't know what else I can tell you. I see your comments in the chat page. Yeah, I think people. I think people have to just recognize that just as they appreciate the made-up words and the little imaginary songs and dances and dramas and the flowers that their kids draw, no matter whether they look like flowers or not, they have to be confident that math grows in the same way and with the same nourishing soil.
Does anybody else have a question? Anybody else? Raise up your hand if you want to ask a question. Well, I want to thank you, Aravinda. That was really, really interesting. Thank you very much. If nobody else has any questions, I'm going to stop the recording. Okay. Anybody else?
Thank you. Thank you very much for your patience and for setting it up.